Okay, so here is our second lesson on our unit on one variable statistics. These are the measures of central tendency continued. This is part 2. But now we're talking about two different topics. We looked at raw data in our first lesson. Today we're talking about weighted means.
Yep.
And we're talking about grouped data.
Yeah. So lots of times, especially, and we do it all the time here when we're teachers, weighted means indicate that certain values are worth more than others. So a test is worth more than a quiz, and the exam is worth more than a test. If I were to just take all your marks, say you've done 20 things for me this semester, and I just add them all up and divide by 20, then that gives equal weighting to the little mini quiz we wrote as to the final exam that we wrote. So one time where you see weighted means, they're really popular, especially with things like course mark breakdowns where we want to say 30% of your mark is this, 20% of your mark is that. Also university admissions, if there's an interview component that you're scored on, and then your grades come in and you're scored on that, and then you've got your resume and there's a written part that you did. Each part is scored, but then they're not all weighted equally. So they need to have a way to give something more weight or count it more than another thing. Same thing in job interviews, depending on the different components, resume, and so on and so forth. So weighted means give you a way of saying this piece of data is worth more, so it's going to count for more of the total mean.
So let's see how we do it. We can use the following formulas. Now, these formulas, just preemptively, they look a lot more scary.
They do a little, yeah.
than they actually are to use, okay? So if you're not a real math person, don't worry. These formulas look a lot more scary than they actually are. So what we do when we're calculating x bar sub w, which is a weighted mean, because x bar is a mean,
Yep.
and then w is just to indicate that it's a weighted mean.
Yep.
What we do is we take each of our data points, so basically the scores you got on each of your tests. So that's x1, that's x2, that's x3, that's x4. So those are the scores that you got on each of your assessments. And we multiply those by
their weight.
By their weight.
If we're going to count it more.
If we're going to count it more, we have to give it some fraction of the total.
Yeah.
So let's say the weight is 20% for tests, then your first test mark, x1, would be multiplied by the weight of the tests, which would be 0 point whatever.
Yeah, could be 0.2, or you could even use 20, and keep it as a percent. There's different ways of doing the meeting, or the weighting for these things.
And then in the denominator, we see the sum of all the weights. So we're going to add up, okay, well, what's the total of all the weights that we've used? So there's lots of different ways to do it. But this is basically what we're looking at.
So imagine, if you will, that each data point is being counted a different number of times. So some data points you might count once, and other data points, if they're worth twice as much, you might say, imagine that you're counting it twice. If it's worth 3 times as much, imagine you're counting it 3 times. And so that in your numerator, the w sub 1 x sub 1 is like, I'm going to count this value twice, plus the next value only once, plus the next value 4 times, and so on and so on. So it's as though you have multiples of some values and only one or fractions of others. So the denominator, it has to be all your weights added up. So if you imagine that you've got twice as many of some values than you do of others, then the denominator, when you add up all those weights, it should sum to the total number of items that you've imagined in your mind, like something being counted twice or 3 times. Right?
That's a beautiful description.
Yeah. Thank you, Mr. Jackson.
You're welcome. All right, so here's a good example, and this is something that you're probably very used to doing perhaps for yourself. So we'll say, for example, MDM4U has this mark breakdown: 3 summative assessments worth 10% each, 35% are what your tests are worth, 15% are what your problem sets are worth, and 20% for the final exam. So let's figure out what this particular student's final grade will be if they got 78% on their first summative, 83 on their second summative, and 56% on their third summative. They kind of let it go at the end of the semester.
Yeah, they weren't caring so much.
Midterm marks were in.
Yeah.
And then problem sets, 86%, tests, an average of 75%, and then the exam, they got 63%.
Yeah.
So let's figure out how we're going to do this.
Yeah, we don't want to just add these 6 values and divide by 6. That would give them each equal weighting.
And the exam is worth more. The tests, this test score is worth a lot. It's
Supposed to
worth
count for
35%.
yeah.
So here's what we're going to do. We're going to say that the weighted mean is equal to the sum of the weight times the item
Yep.
divided by the sum of the weights.
Yep.
Okay. So what does this mean? Okay. Well, here we've got summative 1, which is 78%
Yep.
right here. And so that's our first data point. So it comes down here. So that's our first x, x1. And what's the weight of a summative assessment?
Let's go have a look. There it is.
10% each. So we put weight 1 times summative 1 here.
Yeah.
Then we go on to summative 2. Well, summative 2 is a summative assessment, so it has the same weight, and then there's its mark.
Yeah.
Here's summative 3, and here's its mark. Now we're on to problem sets. Well, problem sets had a total overall percentage of 15%.
Yeah.
And this student happened to get 86% on their problem sets. Tests have a weight of 35%, which gives a total, a total weight of 35%, but this student got 75 on their tests.
That's their X value for that.
Yes,
Yeah.
and so now here is exam. Exam had a weight of 20%, and this student, their X value happened to get 63. So this is how we do the sum of the weights times the marks.
Yep.
We divide that by the sum of the weights. So we had 1, 0.1, 0.1, 0.1.
Yeah.
Then we had problem sets were 0.15. Then we had tests, which were 0.35. And then we had an exam, which is 0.2.
Yep. And
so basically what happens when we put this into our calculator is we get 0.345, 7345
Yep.
divided by 1. And so what this turns into is an overall mark in this course of 73.4%.
Yep. I'd like to point out here that notice that what we did is we took the percentages and we converted them to decimals in every case.
Yeah,
Okay?
and we didn't have to do
You
that.
didn't have to do that. What's neat is if you had imagined it as a score, so 78, 83 instead of 78%, 83%, then all your X values would just be 78, 83, 56, 86, 75, and 63. And if you wanted your weighting to be parts, so 10 parts for this, 10 parts for that, 10 parts for this, 35 parts for that, then you could actually have done 10 times 78, 10 times 83, 10 times 56, 15 times 86, and so on. What would happen though is just that your denominator would now be 10 plus 10 plus 10 plus 15 plus 35 plus 20, which would give you 100 down here.
Mm-hmm.
So you'd actually, you'd have 7345 divided by 100, which would give you 73.4 in the end. So you choose, like you can choose to keep these as percents, right, or as scores and keep them as whole numbers, or you can convert them to decimals as long as you know what you're doing. And it's just that the denominator, if we chose it to put it into parts, then we divide by 100 parts at the end, right? So you've got some options in your weighting.
All right. So now what we want to do, and this is, at this point we have to kind of separate what we've done from before when we worked with raw data.
Yeah.
And we have to pick up that conversation to now we want to deal with grouped data. Because there's many times when you don't have access to raw data, all you have is access to raw data. But you still want to be able to use it. You want to be able to use it to find the mean, the median, and the mode. Mm-hmm. You want to be able to use it eventually to find the standard deviation, et cetera, et cetera. You need to be able to work with data that's been put into intervals for you.
Yeah.
Because very often that's how data comes to us.
Yeah.
And so then the rest of this lesson is about how to deal with grouped data.
That's been organized.
It's been organized
you.
for you. Okay,
and now
so
you're
how?
Deprived of the raw
how?
data.
And so basically, how are we going to figure out what our mean and median and modes are for specifically means and medians? Modes aren't quite as prevalent, but here we have two formulas. Mm-hmm. We got our formula for the population, we got our formula for the sample.
Take note here that because we don't have actual data points, we don't have x sub 1, x sub 2, x sub 3, we've got an interval, and then we know there are a certain number of data points in that interval. So what we have are frequencies, right? Mm-hmm. You've made frequency tables, so you know how that looks. So there's 10 data points in this interval, there's 3 data points in that interval, there's 5 data points in this interval, and we don't know what the original data points are.
Yeah.
But what we can do is we can say, all right, if there's 10 data points in this interval, I don't know what they are, but if I were to find what I think is the average point in that interval, which you know how to do because it's just
The
the
midpoint.
midpoint, which is the two endpoints added together and divided by 2, then what we want to do is we want to pretend there are 10 midpoints.
Yeah.
You know what I mean? Because
There's
we don't know
10
what the 10 data points.
within that interval that
Yeah.
all have the value of the midpoint.
Yeah, so that's the best we can do. So when you see that we want to find the sum of the frequency times the midpoint, imagine that it's, you know, the frequency is 10 and say the midpoint is 7.5, right, that you calculated. Then there are 10 7.5s. And then we're going to add that to the next interval. Maybe there's 3, 9.5s. And then 2 11.5s or whatever it is. So the frequency times midpoint, like don't let that throw you off. The frequency is how many, and the midpoint is our best guess on what all the data points would
Yeah.
be, which is just the average.
Yeah.
So we want some of these plus some of those plus some of those plus some of those, and then we're going to divide by the total number of data points,
Yeah,
which would be the frequency.
Which really, we don't even have to write sum of the frequency. We could write n.
N, yeah.
But it actually makes more sense if we're talking about frequencies. Let's just keep it as the sum of the frequencies.
Yeah.
But make no mistake, if you add up your frequencies, which we've done, either in a cumulative way or
column,
just
yeah.
by finding
the sum.
the sum of all the frequencies,
Yeah.
really that it's just n. It's how many people were in your population, or it's
Yeah.
how many people were in your sample.
Yeah.
And it's basically just the number. But since we're talking about frequencies in the numerator, we talk about frequencies in the denominator as well.
Yep.
Now, the median can be found, or can be, I should say, estimated,
Yeah.
and we'll talk about why it's important that these are estimations. The median can be estimated by taking the midpoint of the interval where the median datum is found.
Right.
So we can figure out, okay, where would the median be? In what interval would that middle data point be?
Yeah.
And then to estimate the median, we simply take the midpoint of that interval.
Because the midpoint is what we're considering to be the average point in that interval, and that's the best we can do because we don't have the raw data. We'll
Okay.
show you how to do this.
Yeah.
It's funny, the median, this isn't a very difficult task, but there's like a little trick to it, and this is the one part that people tend to find the most confusing is
Yes.
finding the median, oddly enough.
Yeah.
We'll show you how to do it.
Okay, so basically, just so that, if you want to take a couple notes on this, F sub I, is the frequency of the ith interval. So some interval, you've got the I, J, K, whatever intervals.
Yeah.
The first, second, third, fourth, fifth interval.
Yeah.
Fi is the frequency of that interval. So F3 would be the frequency of the third interval.
Yeah.
Okay, Mi is the midpoint of the ith interval. So that means if you have 5 intervals, M4 is the midpoint of the fourth interval.
And some of you think of these intervals as rows in your frequency chart, and
Yeah.
that's fine. So then it would be, M sub 3 would be the midpoint of your third interval or your third row down.
Yeah.
Like that's in case that's how you're thinking of it.
Okay, so let's take a look at an example. Now, we're not going to jump right into Excel yet. So we've got a chart here that looks very similar to an Excel chart.
And cell chart, yeah.
And so here's the example. Group of high school students were asked how long they spend on homework a day. Okay, so maybe this is a class, maybe it's a simple random sample, who knows? But it's a group of high school students, and they were asked how long they spend on homework in a day. And so here's what we get. We get a couple intervals up here, and Ms. Hughes will explain these intervals in a minute.
Yeah.
And the corresponding number of students that answered, say perhaps on the survey, how many hours they spent. So now we've picked a little bit of a different notation here, Ms. Hughes.
Yeah. So we wanted to show you another way of writing this that you might see in university. As we said in last unit, your textbook creates endpoints that cannot be data points, like bookends that are not books, as we discussed. But there are other ways of getting around that, and it's using interval notation with round and square brackets. So just as a little short form here, so you can see what you're looking at, the square bracket means equal to, or greater than or less than. So the square bracket includes the 0 point.
Yeah.
Whereas the round bracket at the 0.5, which is the right end of the interval, says up to but not including 0.5. So it could be
we would look at where
4.49999, but not there.
So we would look at then where the next interval begins. Well, it does
Does
include, and then it does not include 1. but this interval does
Does include
include
one.
1, does not include 1.5. Does include 1.5, but does not include 2. Again, this fits our purposes beautifully.
Yeah.
We could have said, you know, we could have gone to the decimal.
And the reason we didn't for this, two reasons. We wanted to show you another way of writing it, but also if 0 is your lowest value, you don't want to go negative 0.5 per
No,
se. Like,
no.
and so sometimes if 0 really is the lowest value, but it is continuous data and you do want, you know, you do want to make a histogram, you do want there to be a shared point between them, but you got to decide which interval to put things in, then you can use the square and round brackets where the left endpoint is always included and the right endpoint is up to but not including. And then that way you can keep repeating the right endpoint along the way. But you know, you don't have to go
Yeah.
negative 0.5
Yeah.
on your, you know, so that helps get around that little problem. Now notice we have amount of time in hours. It doesn't say, you know, interval, but it is an interval, okay? So
Yeah.
so note that. And also it says number of students, and I want you to notice it doesn't say the word frequency because we're using data terminology. We would say that's the frequency of students in that interval, but you'll just see number of students. So translate that in your mind to a frequency, how many
Yeah.
there were in that interval. So frequency and interval, number of students, and amount of time in hours.
All right, so
Yep.
what's the midpoint of this first interval? It's the average of the two endpoints. So
Yep.
0 plus 0.5 divided by 2 is 0.25. So really, the midpoint of this first interval is 0.25 hours.
Yeah.
The midpoint of the second interval is 0.75. The midpoint of the third interval, 1.25, and so on and so forth. So these midpoints become important because here is MI. So this would be M1, this would be M2, this is M3, this is M4, and this is M5.
Yeah.
They become important later because we're going to use them again.
Yeah.
The number of students is, of course, the frequency. The number of students who say that they study between 0 and 0.5 hours a night is 7. And so what we would do here is we would say, okay, well, as we would do earlier, you know, we can find out, well, how many students did we sample? And if we add these up, 7 plus 8 plus 15 plus 7 plus 2, we get a number of 39. So we actually talked to 39 students in this sample. Now, because our formula states that we need to look at the frequency of one interval times the midpoint of that
Same
interval,
Yeah.
and then we need to sum them up.
Okay.
Let's take a look at what these frequencies are.
Now I'm going to pop in just for a second, and this is one spot where students make a mistake, is that once they get the midpoints, I see them just go equals average, and then they just select the midpoints, okay? And the reason that's wrong is that it implies there were only 5 data points altogether, and that you're averaging these 5, and that each one is weighted equally. But this grouped, the reason we put this in with the lesson on how to do weighted means is that it is in a sense a weighted mean. We're saying that there were 7 values at an estimated 0.25, and 8 of them at 0.75, and 15 of them at 1.25. So it's like the frequency is your weight, right?
Yes,
How many
yeah.
how many times are we counting
Because
that?
there's much more students
Yeah.
in the third interval, and we need our average, our mean to reflect
reflect
that.
that.
We need to reflect somehow that, hey, there's a lot more students that are studying at a midpoint value of 1.25 than there are that are at a midpoint value of 2.25. So if we just take the average of this column, we're not reflecting the fact that there's a whole bunch of students that are actually studying in this interval.
Yeah.
And there's very few that are studying in this one. There's less in these two, and so on and so forth.
Yep. Okay, so this Fi times Mi, in your mind, if you want to picture it, it's like the weighting times the estimated x value. The midpoint is our estimated x value because we don't know the real data points. We're saying let's pretend they're all 0.25 for that interval. So this is another way of weighting it because we don't have the raw.
All right, so
Yep.
here we go with the
Yep.
multiplication. 0.25 times 7, 1.75. 0.75 times 8 is 6. 1.25 times 15 is 18.75. 1.75 times 7 is 12.25. And I am doing all of these on my calculator. Okay, so I would sit here and I would calculate out on my calculator bing, 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 all the way down.
Yep.
Okay, this is if I'm doing it by hand. Here, we have our sum.
Yep.
And because what we're looking for is the sum of FIMI, boop, we're going to sum up all of these values.
I get
We get
43.25. So now we're saying if there were 7 of these and 8 of those and 15 of those and 7 of those and 2 of those, that all adds up to 43.25. And now we have to take that and divide it by the total of frequencies, right? So we're going to take 43.25 divided by 39. Now when you do this in Excel, as long as you set up the table right and you have your labels clear, your M's and your F's and your FIMI, then you're really just taking the sum of FIMI divided by the sum of your F's.
Yeah.
Just like the formula, okay? And you'll
Yeah.
have the formulas given to you on the test, so don't
Yeah.
have to worry about memorizing that. So it's relatively straightforward if you think of it like a weighted
Yeah.
mean.
So here we're going to do a cumulative frequency. Of course, we start with 7. 7 plus 8 is 15. 15 plus 15 is 30. 30 plus 7 is 37. And we get up to 39. Cumulative frequency will become important in a moment.
Yes, for finding the median.
All right, so let's finish this off. The mean, we said, was the sum of FIMI
Over sum of F.
divided by the sum of FI.
Yep.
And so here we have 43.25 divided by 39, which we can calculate to being 1.11 hours. So what that means is that of our sample of 39 students, the average number of hours that they spend on homework is 1.11 hours. The median then, and we said that this would become important in a moment, the median, if you will remember, is the midpoint of the interval where the actual median would be found.
Yeah.
So let's go back to this, okay? And this is important because we want to look at this cumulative frequency right here. So we got 7, 15, 30, 37, 39.
Okay.
So basically, Ms. Hughes, explain where we would find the median.
Median. So you know how when we would go in order from lowest to highest and then find the middlemost point, that's how
Yeah.
you do the median when you have the raw data. The nice thing about intervals is they go in order from lowest to highest, 0 to 0.5, 0.5 to 1. So we already can imagine the data that's in there, imagine it is ordered from lowest to highest. Remember how if we have an odd number of data points, okay, so
Which we do.
we imagine that we're like subtracting 1 to get down to 38. And so that means if we cut that in half, there are 19 data points on either side. So that means the 20th data point is going to be my median. If I had the raw data, I would just count in until I hit the 20th,
Okay.
and I would do that. So we need to find the interval where the 20th data point is found.
So it's not going to be in here because this is only to the 7th data
1
point.
and 7.
It's not going to be in here because this is to the 15th
This goes
data
8 to
point.
15. Yep.
This one goes,
16 to 30.
yeah. So it's
in
definitely
there.
going to be in here.
Yeah.
So this data point, this median data point is going to be found in this interval right here. And if we're saying that the median
Is a point.
is a point, we approximate it with the midpoint of that interval, and it's 1.25.
Yep.
So that's exactly why we've said, hey, there's our mean, here's our median, which was 1.25
1.25.
hours.
Yep.
So why are these values approximations?
Well, because we don't have the raw data,
Yep.
we have averaged each interval and then counted that midpoint a certain number of times. But we don't really know. Maybe all of those values from 0 to 0.5 were 0. Maybe nobody does like 15 minutes of homework. Maybe
Yeah.
all of those were 0. And so because we don't know the original raw
Yeah.
data, every single value that we've calculated using the grouped methods is just going to be an estimation. Okay.
So this right here is a simple random sample of car owners. And basically they were asked how old they were when they got their first car. Okay. So we have, this is the data that's given. And what we're going to do is we're going to use Excel to reproduce this chart. Okay, so this chart is the answer. And so we're going to show you how to do this in Excel. So here's what we've been given. We've got age, which has been divided into groups, and we've got then the frequency, so the number of people who bought, who were given or who bought their first car when they were within these age intervals.
Yep.
Okay? So let's take a look at Excel. And so here is an Excel chart that's been set up with our intervals here and our frequencies here.
So we've been given the intervals and the frequencies, and I've just inserted a column for midpoints in between interval and frequency, because that's what we were doing in the last unit. It's just nice and familiar. So remember, if you want to find the midpoint, it's the average of that interval. So it's just the average of the two endpoints. So we'll do equals and then open our bracket, and then we'll do our 15.5 plus 20.5 and the bracket, and then we'll divide by 2. Okay, so we're finding the mean. And then from there, if we look, we've chosen, or we've been given, we haven't gotten a choice here, we've been given an interval size of 5. So if we want, we can just keep taking each midpoint and adding 5, and then we can autofill, once we've performed the first calculation, we can autofill that down. So now we've got all of our midpoints, and we've got, our frequency was given to us. And so what we want to do is we want to say, again, we don't know the raw data, but we know that there are 10 values that we're estimating were points that had values of 18. So when we do midpoint times frequency, we just do equals, click on the cell that has your first midpoint, multiply, so use the little asterisk. I don't know if we've even done multiplication yet, so use the little asterisk for multiplication, and then hit enter. And now because we'd be happy with this moving down row by row, we haven't done any absolute cell referencing, and we can just autofill. So midpoint times frequency, that's great. We know that to find the mean for group data, we take the sum of the midpoint times frequencies, and we put it over the sum of the frequencies. So like at the bottom of each of these columns, we're just going to add up and find our sums. And once we have these sums, then we know that the grouped mean will be the sum of the midpoint times frequencies over the sum of all the frequencies. So we can just type equals, and then we can click on that one and then divide, so / by that one, hit enter. Okay, so our estimated mean for this group data is 25.4. So that's the estimated age at which most people in this sample bought their first vehicle or got their first vehicle. If we want to find the median, it's helpful to do the cumulative frequency, because then you know you're keeping that running total. So cumulative frequency will, the first one is just the first frequency. Okay, so we can hit enter there. And then the second cumulative frequency is going to be the frequency in the first interval plus the frequency in the second interval. Okay, and then the third cumulative frequency will just be the frequency from the, you know, and there are different ways you can go. We can do the sum of those three, right? And then the next one will be the sum of those 4, and so on and so on.
Is there a way to do this so I could autofill down?
There is,
because if I, let's say I had like 15 intervals, I wouldn't want to do this.
You want to do this by hand. So go back to the first one.
that?
Let's go back to the first one, Mr. Jackson, and I'll show you how we can do that. If we clear that and we do equals sum, essentially what we're doing with the running total, we're going to do 10, and then we're going to do 10 plus 18, and then we're going to do 10 plus 18 plus 12, and then 10 plus 18 plus 12 plus 8. Like we're just starting at the first frequency in the first interval, and we're just going to keep adding down. So if we make that an absolute cell reference, then when we autofill, it'll keep returning to that first value. So if we do sum of $C, $2, and then actually back up that bracket, do the colon, okay, and then it is to C2, because that's the one we're in. So if we added C2 to C2, we're just going to get 10, and we can hit enter there. Now if we autofill down, and we'll go ahead and do that, and then we'll click on a few and show you what happens. So let's click on the next one. The next one says, let's do the sum of C2 to C3, which would be 10 plus 18. And then click on the next one. Now we're doing C2 all the way down to C4, which is 10 plus 18 plus 12. So you see how we're doing sums, and we're just building it down so that we keep adding an interval to the bottom of each of these sums. And the reason we do the absolute reference at the beginning is because it is a running total, so we do want to keep going back to the beginning and add them all up. So that's a really quick way of entering your cumulative frequency formula and just autofilling it down.
Okay, so for the median, we need to find the interval in which the true median actually belongs. So there's 50 data points. So there's 25 data points in the upper half and 25 data points in the lower half.
So we need to find where the 25.5th,
Okay.
where the data point that would be between 25 and 26 data point would lie.
So there's 10 data points in this first one, and then in the second one, we're up to 28.
So it goes 11 to 28 in the second interval.
So
Oh,
really,
there it is.
here it is.
Yeah.
In this interval right here is where we find our median, and the midpoint of that interval is 23.
So our,
So our
estimated
median, our estimated median, and we would just write this in, is 23.
And that's by inspection.
Yeah, literally by inspection.
Yep, absolutely.
So coming back to this, we can check this and we see it's exactly the same thing that we just received. And that, ladies and gentlemen,
Is weighted
weighted means and
grouped
grouped
means.
means.